Hello everyone, welcome to this lesson, and the focus of today will be on being able to measure and compare the lengths of line segments. The topic is comparing the lengths of line segments. You've probably been doing lots of comparing, measuring ever since you started school, and that's going to be the focus of this lesson. But of course, you might think you know all of it, but it's important to pay attention. So our lesson is lesson number 2 of this chapter, and the learning goals of today will be understanding the nature of the shortest distance between 2 points and the concept of the distance between 2 points, understanding the concept of the representation of the midpoint of a line segment, and having the ability to compare the length of 2 line segments with tools such as rulers. Well, the third one, simple enough, comparing the lengths of 2 line segments with rulers. Understand the concept of the representation of the midpoint of a line segment. All in the first one, of course. They might seem a bit confusing, but that's exactly the concepts we'll be learning in this lesson. So here's the introduction. As you can see, this is a quick map. Tommy is thinking, which way to school is the quickest way? This is Tommy's house, the post office, the school, and supermarket. Path number 1 is from Tommy's house to post office to school. Path number 2 is Tommy's house, supermarket to school. And the third one is Tommy's house straight to school. That leads to the concept we'll be learning today, the first one. The shortest distance between 2 points. Here's what I mean. As shown in the figure, there are 4 roads from A to B. Can you find the shortest road from A to B besides these paths? What other way can we connect A to B that's the shortest? The answer will be the straight line. Because this will have to go loop all over. This will still have to loop. This is also looping around. This is another loop. So a straight line will be going right across while the other, so say we're having a race. If, say, the finish line is right in front of you and you could just go straight ahead, but your other the people you're competing against, they have to curve all around a huge lake, who will get there first? You, of course, because you're running straight. So here are our observations. Among all of the paths between the 2 points, the straight line segment is the shortest distance. So here's the conclusion. These findings can be summarized as: between 2 points, the shortest distance is drawing a straight path through the middle, and we call the line segment between 2 points the distance between the 2 points. This is a key point here. Between 2 points, the shortest distance is drawing a straight path through the middle. Remember, straight. It can't be loops. A straight line segment right through the middle. Jot this down in your notebook. Okay. So, here is example number 1. I will be walking us through together. As shown in the figure, the line MN represents a railway, and the points A and B are on both sides of the railway, representing 2 factories. To build a cargo station on the railway to minimize the sum of the distances from 2 factories, where should this cargo station be built? Okay, let's go over what we know. As shown in the figure, line MN represents a railway, so NN, this is a railway. Points A and B are on both sides of the railway, representing 2 factories. So this is factory A, factory B. They want to build a cargo station on the railway, that's what highlighted it, to minimize the sum of the distances from the 2 factories. So we're being asked, where should this cargo station be built? Well, first, the cargo station has to be on the railway. And before we even think about the cargo station at all, let me ask you a question. If we just look at, without the line MN, if we just look at points A and B, What will be the shortest distance to go through them? Yep, using the observations and conclusions we just got, we can know that the straightest distance from A to B itself, without any conversations, will be just a straight line segment right there. And it has to be on the railway. So if this is the shortest distance between A and B and we want to minimize that, it has to be on the railway. Which part of it is on the railway? This part. So the answer will be right there. Here's a conclusion. 1. The concept of the distance between 2 points refers to the length of the line segment connecting 2 points, not the line segment itself. And 2. When solving problems such as choosing a location and finding the shortest distance, it is usually the shortest line segment between 2 points. This is a conclusion here. Now we're going to get into our second concept we'll be learning today. Comparing the length of 2 line segments. Discussions. Which tree is taller in the picture below? Which pencil is longer? How do you compare? Well, of course, we have a trusty ruler, and we can also tilt that horizontally to measure horizontal objects. So think, how do you compare the length of these 2 line segments? Line segment AB and line segment CD. First is measuring directly. We can use a ruler to measure, so we can find their individual values and then compare which value is larger, which value is shorter. And we can also stack one of these line segments on top of the other so that each endpoint on one side lines up. The segment that reaches further out is the longer one. So that would be stacking figures. So how stacking figures works is that it doesn't the question is asking you to compare it, not to find the actual value of the length of each line segment. So, without using a ruler to measure, you could just stack them. This will be demonstrated, so we bring a copy of this line segment, overlap it onto line segment CD. You can see that CD is longer. But of course, if these line segments are super duper close, it will probably be nicer to just ensure that your answer is correct by using a measuring tool like a ruler. Now here's the last, or maybe close to last, concept of today. Discussions. How do you find the midpoint of a rope? Can you describe the midpoint of a line segment? Use the demonstration below. So what this is asking you to do is not just showing it, not just finding it because it's already there, to describe M. Why is it the midpoint? What makes it a midpoint of the line segment? Well, here's a few ways to put it. The point M divides the line segment AB into smaller, equal line segments, AM and BM, so that point M is called the midpoint of the line segment AB. So what this is talking about is M divides the line segment AB into smaller, equal line segments. So each smaller line segment made by M, which is AM and MB, has the same value. It's dividing the line segment into 2 equal parts. So here's a mathematical description. Because M is the midpoint of AB, then M is equal to MB, which is equal to 1/2 of AB. Or AB is equal to 2M equals to 2MB. Now here's a practice problem. As shown in the picture, AB is equal to 6 centimeters, point C is the midpoint of AB, and point D is the midpoint of CD. Find the length of AC and AD. Okay, so let's review the problem and go over what we know. So we know that AB is equal to 6 centimeters. So our 6 centimeters will be, over here is, I'll write 6 centimeters. That's a whole thing. And C is the midpoint of AB. And point D is the midpoint of CB. So find the length of AC and AD. Well, we first need to know that AC and CB are equal, and they are both exactly equal to 1/2 of 6 centimeters. So if this whole thing is 6 centimeters, and AC and CB each is 1/2 of 6 centimeters, then this has to be 3 centimeters, and this has to be 3 centimeters. Okay, now we know that point D is the midpoint of CB. So out of that, we can draw another separate line segment, which is a zoom in of that section. So here's CB, and the midpoint is D. So these are exactly equal, and this whole thing is 3 centimeters, right? 3 centimeters, 3 centimeters. So CD and GB are the exact same, and they are the exact same also as 1/2 of 3. Well, what's 1/2 of 3? 1/2 of 3 is 1.5 centimeters. So this part is 1.5 centimeters, and this point is 1.5 centimeters. I'll just write 1.5. Our answer, what is asking the length of AC first, AC. Know that AC is equal to 3 centimeters. And AD, but we don't know AD yet. Okay, but we do know that this portion, CD, is 1.5 centimeters. And if you look at the picture, you can see that AD, which is this part, is exact same as AC plus CD, right? This part is AD. So we add 3 centimeters to 1.5 centimeters, and we have 4.5 centimeters. So now let's look at the solution. AC is equal to 3 centimeters and AD is equal to 4.5 centimeters. Easy enough. So here's a conclusion. Methods of finding the length of a line segments. Tackling directly, which is using the ruler to first measure each line segment and then compare using the numbers. And 2, overall conversion. So it's basically stacking or transforming to sum of 2 line segments. You all know this. And here's the example. As shown in the picture, points B, C splits AD into 2 to 3 to 4 ratioed parts, and point E is the midpoint. EC, and if EC is equal to 2 centimeters, find 1, the length of AD, and 2, AB to BE, the ratio of that. Now this might seem really tough, but I want you to just pause the video and try to solve this word problem. Is there a special way you could figure it out? Okay, so I'm curious to figure out what you thought. Well, the solution is, first we set AB as 2x. AB is 2x. AB, 2x. BC is 3x. And CD as 4x. Oh, actually, and also this is set the same way. So this, if you're confused on why we're doing this, is just to solve the problem. And usually when you meet questions with ratios, it's usually just good to turn them into 2 times, 3 times the same something, and 4 times the same something. So BC over here is 3x and CD is 4x. There. Anyways, so from the sum and difference of the line segments, we get that AD plus AB, no, AD is equal to AB plus BC plus CD, which is equal to 9x. Remember, this is the combining like terms. We add up all of the small line segments and combine like terms, which is 2x plus 3x plus 4x, we'll get 9x. So from E as a midpoint of AD, ED is equal to 1/2 of AD, which is equal to 9/2 x. And from the sum and difference of the line segments, CE is equal to DE minus CD, which is equal to 9/2x minus 4x. It's equal to x/2. It's equal to 2. So CE is equal to 2. So we solve, and x is equal to 4. So we go back to the beginning, remember, because it's not just the answer is 4. Remember, it's over here, so we plug x as 4. So 4 times 9 is equal to 36 centimeters. That's our first one. Now we have AB to BE. The solution for that is AB is equal to 2x, which is equal to 8, and BC is equal to 3x, which is equal to 12. AB is equal to 2x, which is 8. Remember, x is equal to 4. And BC is equal to 12. So then, BE is equal to BC minus CE, which is equal to 12 minus 2, which is equal to 10 centimeters. So, AB to BE is equal to 8 to 10, which is equal to 4 to 5. So here's our summary. From the sum and difference of the line segments, CE is equal to DE minus CD, which is equal to x minus 4x, which is equal to 2. The solution is 4x to 4. When encountering the problem of the ratio between the line segments, the unknown numbers often set up and the equation is solved. So here's class summary. We learned all about comparing lengths of line segments, and we learned about all 4 topics. So 1. The shortest distance between 2 points. The shortest distance between 2 points is the straight line segment going through them. There's also methods of comparing lengths of line segments. We learn about different methods, visualizing with a ruler, and the sum, difference, multiple, and parts of the line segment. And from the methods of comparing lengths of line segments, we learn all about measuring directly with a ruler and when comparing, also by stacking figures. Here are the 3 skills we learned. First, understanding the nature of the shortest distance between 2 points and the concept of the distance between 2 points. 2. Understanding the concept of representation of the midpoint of a line segment. And 3. Having the ability to compare the length of 2 line segments with tools such as rulers.